All right, 6.2. 6.2 is not much different than 6.1. We're still going to be graphing quadratic equations, only now we're going to do it to solve them. Okay, when a quadratic function is set equal to a value, you get a quadratic equation. So we're going to have ax squared plus bx plus c equals 0. Okay, we always want it to be equal 0. So if this is a number over here, you want to move all the numbers over to the left. We always want it to be equal to 0. The solutions of a quadratic equation are called roots. They're also sometimes called zeros. So we'll be hearing that term used as well. So roots or zeros or solutions or answers, those all mean the same thing. All of these solutions or roots are related to the x-intercepts of the graph of the quadratic function. So what you're going to be thinking about is, if this is graphed, where does the graph hit the x-axis? And if you think about that, up here, if we were putting this in our graphing calculator, we would put this side into y1, and we would put this side into y2. So y would be equal to 0. And where does y equal 0? Y equals 0 is the x-axis. So we're going to be looking for those points right along the x-axis. All right, key concepts. A quadratic equation can have one real solution, two real solutions, or no real solutions. When you look at the graphs of these, you can see this very easily. Okay? It would have one solution if it hits the x-axis one time. It would have two solutions if it hits the x-axis two times. And it would have no solutions if the graph doesn't touch the x-axis. Now notice that they say real. Okay? Real solutions, not imaginary. Okay? One real solution, two real solutions, no real solutions. What actually happens down here is you get two imaginary solutions. Alright, so we're going to start by graphing x squared minus 3x minus 4 equals 0. So we're going to have to go back to 6.1 and think about how did we graph those. Okay? Now you can make this table of value, but remember the table of values we wanted to start with the vertex. So to get the vertex we want to do the opposite of b over 2a. The opposite of b over 2a. So the opposite of 3 is 3 over 2 times 1 is 2. So 3 over 2 is 1.5. Now how do you get this y value? You simply put 1.5 in to your equation. So 1.5 squared minus 3 times 1.5 minus 4. Okay? So you want to figure out what that number is. You can use your calculator to help you. And what you're going to find is that that's negative 6.25. Now if you want, you can make this big table, or you can just do a little mini table. That's up to you. Alright, so we get the vertex, which isn't in a nice spot. That's okay. And then you want to pick some points to the left or to the right, and then you can map them over. So I would have probably said, if I'm going to have my vertex here, what happens if I put in 0? Because 0, when you plug that in, is real easy. It's 0 minus 0, so it's negative 4. So I would have said at 0, negative 4, and then I would have thought about my axis of symmetry, and I would have mapped that point to the other side. Okay? Now it's important that you make your graphs big enough that they cross the x-axis, because now that we're solving quadratics, we want them to cross the x-axis. So see, these 2 points down here are not very helpful. They're just giving us ideas from this big chart. Where can we get this big chart? We can get it off of our graphing calculator. If you type this into y equals x squared minus 3x minus 4, you can get this chart. Now you're not going to get this vertex because it has decimals. So you have to do the vertex by hand. Okay? Once you have the graph of this, you can see where does it cross the x-axis. Well, it crosses the x-axis there and there. So what are those two spots? Let me erase this here. That's negative 1, 0, and 4, 0. So we would say that the solutions, or the roots, or the zeros, are negative 1 and 4. So that's what you're trying to find, is negative 1 and 4. Okay? You don't have to write them as points like we did up here. Okay? So try another one. X squared minus 4x equals negative 4. Okay? We want it to always be equal to 0, so we move this negative 4 to the other side. Okay? At this point, you could put it in your graphing calculator, and we'll talk about the graphing calculator in class. Okay, doing it by hand, because it's important you can do it by hand. First, get the vertex. The opposite of B is 4 over 2A, so our vertex is 2 something. How do you get the something? Just plug the 2 in. Okay, so you're basically making a little chart, and you're putting 2 in. So 2 squared is 4, 4 minus 8 is negative 4, plus 4 is 0. So we know that the vertex is 2, 0. Again, this big chart you could get off your graphing calculator. You don't really need to make that big chart. You've already got a little chart started over here. 2, 0. Okay? Pick something else. Maybe you'll pick 1. When you put 1 in, what do you get? Well, since we already have the chart, we can see that it's 1. Once you get this point, think about your axis of symmetry and just map this other point over there. Okay? That would be enough, because what are we really looking at? Only where does it hit the x-axis. So these points up here don't really matter. You only need to have a little bit of this graph. This graph only touches the x-axis one time. And it's at what point? 2, 0. But we want to say the 0, or the root, or the solution, is simply 2. So you don't have to write it as an intercept. Okay? Another example. X squared minus 4x plus 5 equals 0. Again, find your vertex. The opposite of B is 4 over 2, which is 2 something. So you might want to just make a little chart, or I'll put the big chart up. If you put 2 in, what comes out? 4 minus 8 is negative 3, plus 5 is 2. So if you get your calculator and you put it, oops, I got 2 and it says 1. So did I do math wrong? 2 squared is 4 minus 8 plus 5. That's negative 4 plus 5, which is 1. Okay? Graph that. So graph your vertex first. Then put more points in. Okay? So I'm going to put in 1, because it's to the left of my vertex. If I put 1 in, I get 1 minus 4 plus 5. That's negative 3 plus 5, which is 2. So I would plot this point. I would think about my axis of symmetry, map that over there, and then draw this. See, mine isn't even going to be as big. The reason why you don't need to make it as big is you only want to look at the x-axis, and you can see this is not touching the x-axis. So there are no x-intercepts. Therefore, there are no real solutions. What we will have are imaginary solutions, and we will get to imaginary ones at a later time. So all of these examples have been written in this quadratic form with the A, the B, and the C. So we use this to help us find our vertex. And they can be written in the other form as well, which in this book they're calling standard form. I sometimes will call this HK form. Other people will call it vertex form. All of those are fine. I call it HK. HK is the vertex. That's the same difference. So remember, in this form, you can tell all of these things by looking. So the vertex is HK. Remember, if this coming out of the parenthesis, it changes its sign. So it's negative 5, negative 1. How does it open? Well, you look right here. If that's a positive, it opens up. Okay? I'm going to erase those because they're going to come in typed. But that's what you're thinking when you're doing this. Okay? So you want to graph that vertex point, negative 5, 1. Now you're thinking, this opens up. So I'm going to go up this way with my graph. So I need to figure out what's my axis of symmetry. What is that line? That's x equals negative 5. Now, how will we get our other points? Just make a little chart. So I did negative 4, and I plugged negative 4 in. Negative 4 plus 5 is 1. 1 squared is 1. Minus 1 is 0. Then I plugged negative 3 in. So I was able to get these points. Where does it cross the x-axis? So we can draw the graph in. Where does it cross the x-axis? At negative 4 and negative 6. So that's all you're looking for, is where it crosses the x-axis. Now we'll also do some little word problems. Now when we do the word problems, we're going to use our calculators to graph them to help us. An arrow is shot upward with initial velocity of 32 feet per second. The height of the arrow is given by h of t, where t is time. Okay? So you're given an equation. H of t, the height and the time, is given by this equation. So you don't have to figure the equation out. All you're going to do is graph it on your graphing calculator. Now for me to make the calculator work, I have to get out of this view. Alright, so if I want to see my calculator here, I simply want to graph the problem. So we're going to go y equals and type in 32. Now use an x, because you can use a t if you want, but it's just as easy to use an x, minus 12x squared. So this is what you'd be doing if you want to get your table of values anyway. Now in y2, you want to put 0. If you don't, you won't be able to calculate any intersections. So hit graph, and depending on how your graph is set up, okay, if you zoom 6, this would be our standard look. Okay? So we can see that it went up and came back down. If you want to see that again, you have to zoom it differently. Some people will just use zoom out. Remember, you have to press enter for that to actually work. And you can see that that's what your picture looks like. But it's really tight now. So that zoom isn't very good. I'm going to put it back to standard. All we care about is where the x-axis. Okay? We know that's up there. If you want to see where that is, change your window. Your y maximum is only going to 10. Maybe make that go higher. Let's pick 30 and see what happens. Okay, so now you can see it because I made that taller. Okay, so we're standing right here at the vertex. We shot the arrow and it came back down and hit the ground. So this part of the graph down here doesn't make sense. It's under the ground. Okay, so what's the question here? How long will it till the arrow reaches its maximum height? So we want to know what the time is up here. Now that's the vertex. So we could do the opposite of b over 2a. But understand, this is the a and this is the b. As far as the graphing calculator is concerned, we can find that point by calculating the maximum, number 4. So it wants you to be to the left of that point. So move your cursor up a little bit. You're to the left of it. Press enter. Move to the right of it and press enter. And that will find the vertex for you. Okay? So there's the vertex. Okay? So how high does this point go? 21 1/3. Okay? How long does it take to get there? That's the x. So x is time, remember. So it takes 1.3 seconds to get there. It gets there, it's 21 1/3. Is it feet? Feet high. Okay? When does it hit the ground? So we want to know what is this point right here? You can calculate the intersection to get that point. And you should know how to do that. We'll talk about the word problems in class.